Aloha and welcome to this short screencast where I'm going to attempt to introduce you to the similarities and differences between Java and JavaScript with respect to object orientation. And I'm calling this quick and dirty for beginners because the differences between these two things and the subject of how languages like Java and languages like JavaScript differ with respect to object orientation is quite a complicated topic. And actually, when you Google on this stuff, it can be fairly, slow going, okay, to tease out things. So what I'm trying to do here is actually give those of you who are new to JavaScript and maybe even relatively new to Java a very 30,000 foot level understanding that enables you to get a little traction with respect to working with these languages or moving from one language to the other. That's what I'm trying to do here. So I'm going to gloss over certain things, but my belief is the essentials will be good enough to get you going. So when we say object orientation, what do we actually mean? All right, objects, very simply, are things that combine state. Okay, so the values of fields and behavior, which are functions. And that was the fundamental thing before, Simula or SimScript back in the, 70s. Programming languages didn't have this ability to combine together, data fields and the functions that operate on them in a convenient way. So that was a huge breakthrough because it turns out that in the real world, when you're trying to model problems like cars or people or bank accounts or whatever, this idea that you can have state and the operations that operate on them and combine them together in a construct is very convenient. It makes it easier to model real-world things. So when we talk about object orientation, ultimately we're just talking about the ability to combine state and behavior. There's of course lots of other things, inheritance and so forth, but again, we're glossing that over for now because this is the convenient way to kind of understand at an introductory level the differences between the two languages. So what I'm going to do first is I'm going to talk about the syntactic differences between Java, in particular ECMAScript 6, okay, which came out in 2015, all right, so it's pretty recent, and the long-standing Java object orientation constructs. And then I'm going to go into the semantics, and that's where things get a little crazy. So let's start. So what we're going to do is we're going to look at kind of the simplest object-oriented example that I could think of, which is a square. If you want to represent a square, you have one piece of state, which is the side of the square, because squares, all four sides of a square are equal. And then the behavior, one behavior on a square. You can have perimeter or whatever, but we'll calculate the area, which is just, one side, the side squared is the area of a square. So we've got one state variable, we've got one function. Let's look at it in Java. Here's the code for it, and in fact it's not only the code for defining a square, but it's also, you can see at the bottom, I have a main method where I create an instance or an object, a square object called mySquare, and then I print out the value of the state, and I compute this behavior, which is area. Okay, so how do we do this? And I'm using kind of the standard Java beans idiomatic design philosophy in Java. You don't have to do this, but generally, good object-oriented programmers in Java are going to declare their state variables to be private and only allow access to those variables through some kind of public accessor function. So we have a getSide method, which in this case just returns the side variable, and we've got a constructor here which initializes the object with its side. So you can't create a square without knowing what its side is, and it just stores the value that's passed to it in this this instance variable. We compute the area, and then we just have a little main method to exercise that. Okay, so very straightforward. Let's look at the same thing now in JavaScript. Okay, well, really, if once you get past the initial, there's a few little things that are different, but really it looks pretty much the same. So we're going to define a class, call it square. We have this special function called constructor, which is what we can pass the value of side in, and then we set an instance variable to be the value of the parameter. And then we declare a function called area, and it's just going to return that instance variable squared. To create a new square, we call new square with this name. And then to print out the state and behavior, I'm using the console to do that because that's how you do it in JavaScript. It looks pretty much the same. So if you look at these two things, they're pretty darn similar, okay, which is kind of actually an interesting thing, which we'll see in a few minutes. Like, why are they so similar? Because really under the covers, they're like totally different. Okay, so let's look at a few things we notice. One is that in Java, you notice there's these public, everything's like public or private, and there's a protected as well. So access control is a big part of Java, where you're defining the visibility of things. This goes back to famous work in software engineering on information hiding and how important it is for things like a class or an object to protect certain kinds of information. In this case, the information that's kind of protected is this instance variable, and we're controlling access to it. And you can see there's no good way on the surface to get at that, to change the value of this side variable once it's created. Actually, you can, but it's not easy. Okay, or at least it's really clear what the programmer's intent is that you not do it. Okay, in JavaScript, no such access control. Okay, everything in Java is visible. There's you can't declare this instance variable to be private. In fact, the other thing, let's see if I, so in JavaScript with respect to access control, you basically do it by convention. So you might preface a variable name with an underscore to say, hey, this is something that external clients shouldn't be messing around with, but there's no actual construct within the language like Java has. Second thing is, in Java, you have to explicitly define your state. So we go back here and you can see we've got this definition private inside that specifies there does exist this instance variable. In JavaScript, there's no declaration that there's this instance variable. Instead, you just kind of basically assign something, and you're kind of dynamically creating a property called side on this object, when as part of the constructor. So it's more implicit, the way that you're creating state. And in fact, you can create state at any time. It doesn't have to be in the constructor that you create the state. You could have within the area method, you could be suddenly adding properties to your object, and that would be totally fine. So it's more implicit, and I do it in the constructor just because in this particular example of a square object, that's where it makes sense to do it. So thirdly, when we look at the way you create these objects in these two constructs, other than the fact that in Java you have to actually declare the type of the variable, there's almost character for character no difference between the two. Okay, so they look pretty much the same, and interestingly, that's either a bug or a feature depending upon how you look at these things. So we see the syntax of these two things, and what we can see is Java is more verbose, it's more explicit, it's got all this stuff for access control, but otherwise, really, basically, they don't look that much different. Okay, and I think that's intentional. And what it means is that if you're building simple kinds of objects like squares, where you just got some, state and you got a few methods on it, you can go ahead, if you're a Java programmer, and just kind of learn the syntax of doing it in JavaScript and see how it's, a little, less explicit, and, you got to learn about that constructor function, and you're pretty much okay. And things will pretty much work as expected. Okay, so that's kind of cool. The syntax is pretty close. Okay, however, despite the fact that at a superficial level there's a lot of syntactic similarities between the two, it's important for you to note, even when we're just looking at this at the 30,000 foot level, that in fact under the covers things are completely different. Okay, and so I want to spend a few minutes just kind of giving you a taste for what that means, because later on, as you stop doing like simple object-oriented systems and kind of find yourself going into more complicated scenarios, you might have to have a deeper understanding of this. Okay, so at least at that point you'll go, oh, wait a second, this is prototypal inheritance, and I gotta think harder. So classical object orientation, which is what C++ has and Java has, and most of those imperative languages. I don't know, Ada, what the heck else? Scala, I think, probably has classical O. So I take that back. I don't know about Scala. So the idea, the metaphor is cookie cutter. Okay, so you have the dough, which is the objects, and then you have the cookie cutter, which is the class. And the dough is made out of flour, and the cookie cutter is made out of metal. They're completely two different things. Okay, and you build this cookie cutter out of metal, and it's kind of rigid. And then once you got it, you bang out your objects by kind of using this cookie cutter on the flour. Okay, and that should be, if you come from the Java world, you might wonder, well, how the heck else could one do object orientation? Isn't that just like the way it is? Turns out, no, there's a completely different way to think about it. And that's called prototypal OO. And what that means is, in prototypal OO, there really is no class. There's no cookie cutter. There's no metal thing. There's only flour. Okay? There's only the objects. And you create any new objects by starting with some other object or the blank object, and you kind of clone them. And so the metaphor for prototypal OO is not cookie cutter, but I think the best metaphor is mitosis, which is how cells divide. Okay, so if you think of your body and the cells in them, there's no cookie cutter like stamping out new cells. Instead, you have one cell, and at some point it says, we need another cell here. Okay, I'm going to divide in two, and then there'll be two and then there'll be two cells where previously there was one. And this is called mitosis, the miracle of life. Really awesome thing, and that's more kind of like the JavaScript idea, where we only have cells. There's no higher level concept, and we create one cell from another. And then, kind of to extend the metaphor a little farther, you can't go too far with this metaphor, but to get a little farther is, once you've got these two cells, they're living their independent lives, they could change from each other. Okay, so whereas in the cookie cutter thing, kind of the metaphor is, once you stamp these things out, these guys are always going to be identically equal. In a mitosis scenario, these two cells, as they live their life and are impacted upon by nature in different ways, they could end up being very different from each other. And that is also true of JavaScript prototypal object orientation, and leads to kind of a flexibility in the way you design your systems that's not really present in classical OO. And the prototypal zealots will really key in on this as being a cool feature. And it is a cool feature, but many times you don't need that feature, and you can actually not have your cells change at all once they've been created, and it kind of devolves back to a more classical scenario. But the way that things work are fundamentally different, right? Cookie cutter versus mitosis. Those are just really different ways of thinking about things. Okay, so if I've just spent the last couple of minutes saying in JavaScript there's no class object, there's no cookie cutter, then why the heck does JavaScript have a class construct? Okay, that's crazy. And it is indeed totally crazy and like totally misleading. All right, and my basic sense is that JavaScript in ECMAScript 6, they came out with this class construct because they realized that to a first order approximation, most people in 50, 80, 90% of the time, they can use this construct. And even though it's actually syntactic sugar over a classless world, this prototypal inheritance, it would still end up working the same way Java people are expected to see objects work in a classical domain. So it's just, they called it class because they said, at the end of the day, people writing code with this, that's going to be more familiar to them, and to a first order approximation, it's going to work the way they expect it to work. Okay, so for simple situations like our square, problem, prototypal OO works effectively the same way as classical OO works. Okay, and so they get away with this class construct, and there are some people that are really bummed out by the fact that they called it that. But that it is what it is. Okay, so I think mainly, if you just understand this, then you'll be fine. Okay, so it turns out that this class construct is completely unnecessary. The class construct is completely necessary in Java. If you didn't have the class construct, you couldn't make objects. Okay, but because JavaScript already had objects, right? And all of you know this if you've taken the intro JavaScript online courses, you'll learn that there are arrays which start with square brackets, and then there are objects. They call them objects. They start with curly braces, and they've got a key, and then they've got associated with the key's values, and it's untyped, so you can have any kind of value associated with a key. And so what I'm showing you here is an object that has state and behavior, so therefore it's object-oriented, which is good given that we're dealing with objects, right? You would hope that the object construct in JavaScript would be object-oriented. So we've created this MySquare. We're not using the class construct, and in fact we can do the exact same thing with it that we were doing with the class construct, which is we can get the value of state by getting this property, and we can invoke the function associated with this property, which is going to return the area. Okay, so super interesting, right? We didn't really need that class construct. We could have used this much simpler mechanism and achieve the exact same effect. Okay, so why did we need the class construct? Why is that even there if in fact we already had objects with the curly brace notation? And the reason is that with prototypal O object orientation, if you don't have the class construct, things get fairly complicated fast, and you need to understand it at a much deeper level to make any progress with it. Okay, so to show you that, what I'm going to do is go into JS Fiddle, which is a cloud-based environment for evaluating JavaScript code, and just show you a couple things. Here I've just, I've got that same object which has state and behavior, and then the first thing I'm going to do is run this to show you that in the console, when I say mysquare.side, mysquare.area, I get 5 and 25. So this actually works the way we'd expect it to. The second thing I'm going to do is now I'm going to run it with that change, because I want to show you what this object looks like. Okay, and it looks exactly like what you'd expect if you've ever used that curly brace notation, which is that it's an object and it has a state variable called side, which has the value 5, and it's got this other thing called area, which is itself a function, and you can find out more about it. Okay, so that's cool. Okay, that so far so good. All right, so let's comment that out. Now what I'm going to do is I'm going to create a new object from the old object, and this is the standard JavaScript notation for mitosis. Okay, so I've got my object called MySquare. I'm going to create a new object called MySquare2, and then what you can see if I now run, I can do mysquare2.size and mysquare2.area. Okay, if I run this, what you'll see, mysquare2.side, that would be better if I spelled things correctly. Okay, if I run this, what you can see is I get exactly the same behavior as I got with the MySquare. Okay, so far so good. All right, where things get a little bit different is if I now look at this object. So if I run this, what you can see is whereas before I had this object with a value side 5 and an area function, now I get what appears to be an empty object. Okay, now that's kind of bizarre if you think back to what I just did before, which is I was calling the side I was invoking the side property, invoking area, and everything worked fine. Well, how does an empty object actually have this state and behavior? And the answer is that when you create these copies with prototypal OO, it's not really mitosis anymore, because the two things don't result in exactly the same structure. What happens is the second object that you create, it's preserved in this underscore underscore proto underscore underscore, which means please don't tamper with me. That's where it's saved the original object. So basically what it's saying is, and it turns out that when you actually invoke the side property of my square 2, it's going to look and say at the top level, is there any side property? Well, if not, I'm going to go inside this underscore underscore proto underscore underscore thing and look and see if I can find it there. And if I can't find it there, if there's an underscore underscore proto in there, I'll go look under there. Okay, and oh my God, look at all this stuff that's like showing up now. Okay, so this turns out to be in prototypal inheritance really nice, because it enables you at the surface to kind of deal with my square 2 as if it were exactly the same as my square. You can call the side property, you can invoke area and so forth. But under the covers, representationally, you're preserving the object that my square 2 came from, or that the structure of the my square object. And in fact, we have this what's called the prototype chain, because in fact, our original my square object came from someplace as well. Okay, so that's why under the covers, prototypal inheritance gets really complicated. And if you don't have that class construct, setting things up correctly so that you get the right kind of behavior when you do this create is non-trivial. It requires a lot more understanding of the way JavaScript implements functions and objects and so forth. So what they did in order to deal with that is they decided, let's go and build a new construct called class, so that people who come from Java and other places, they can start off using object orientation in JavaScript quickly, and for simple cases, it's going to work. Okay? I think it's a good answer. I support it. Okay? Even though it's like a white lie, but a white lie that enables people to get off the ground way faster than they were before, and actually write systems that work correctly for, the basic kind of cases more easily. And look at the code. The code is really simple. Okay, so in summary, what we know is object orientation. What is it about? It's just the ability to combine state and behavior. In JavaScript, we have this relatively recently defined class construct added to the language, which makes their very different version of object orientation, called prototypal object orientation, easy for regular programmers who come from a Java or C++ background to get started using quickly, and things are going to work appropriately. However, under the covers, they're really different, and it provides capabilities not present in classical OO. So as you go from the very beginner level to the intermediate or advanced levels, you want to eventually really understand prototypal OO so you can take full advantage of what is actually a super cool construct for software development.